Our technique of stopping the denominator works for other limits at infinity. You just have to know which term is growing fastest. So in this problem, we have a bunch of e to the x's. Now think about as x tends to infinity, let's think about the graph of e to the x. The graph of e to the x goes like this, right? So e to the x is growing. E to the negative x, though, is that graph flipped around the y-axis. So e to the negative x is fading away. So if we look at this denominator, which term is growing fastest as x tends to infinity? Well, it's the e to the x, right? That's the one that's growing. E to the negative x is actually fading to 0. So what I should do to stop the denominator is to divide by that fastest growing term, which is e to the x. When I do that, in this problem, in the limit as x tends to infinity, we have, let's see, e to the x divided by e to the x would be 1. E to the negative x divided by e to the x, if we subtract exponents, we get e to the negative 2x. Okay, and down here, e to the x divided by e to the x is going to be 1, and e to the negative x divided by e to the x is going to be plus e to the negative 2x. Now let's think about this. E to the negative 2x fades away as x gets larger, so this limit is just going to be 1 over 1, which is 1. On the other hand, if we have x going to negative infinity here, then the fastest growing term, if we think about e to the x and e to the negative x, as we go backwards, e to the x actually fades away, right? It goes to 0, but e to the negative x is growing. So what we're going to do is stop the denominator by dividing by the fastest growing term, and as x goes to negative infinity, we decided that fastest growing term was e to the negative x. So we do that, we get the limit as x tends to negative infinity of e to the x divided by e to the negative x. If you subtract exponents, you get e to the x plus x, that's e to the 2x. You take e to the negative x and divide it by itself, and you get 1. Same thing happens downstairs. We get e to the 2x, but plus 1. So e to the negative x divided by e to the negative x is 1. E to the x divided by e to the negative x is e to the x minus minus x, e to the x plus x, e to the 2x. Okay, now again, let's look at the graph of e to the 2x. The graph of e to the 2x is like the graph of e to the x. It just grows as you go to the right and fades away as you go to the left. So looking at that, we know that the limit as x tends to negative infinity of e to the 2x is 0. So this is going to 0 minus 1 over 0 plus 1. So the limit in this case is negative 1 over 1, or negative 1 in the long run. Just for fun, let's draw the graph and just confirm what we've already shown algebraically. Our function was e to the x minus e to the minus x, all divided by e to the x plus e to the minus x. So on the one side, it's coming up to 1. On the other side, it's going down to 0. Let me just zoom in here a little bit so that my y range is stretched out a little bit, and we have this function that moves from, as you go backwards, it approaches negative 1, and as you go forwards, it approaches 1. It does it pretty quickly because it involves exponentials. Exponentials grow rather rapidly, so you get a pretty quick change there in the function.